In this video, I will explain that how principal component analysis can be used efficiently to select the most influential general circulation model for climate studies. Instead of analyzing every model separately, principal component helps us to identify dominant patterns, reduce redundancy, and improve computational efficiency. We will generate a Scree plot to visualize variance explained by each principal component and compute component loading to understand model contribution. Instead of using other visualization technique, we will use a bubble chart with dynamic color palettes to highlight the most impactful model. So now let's visit the code. So here you can see I have imported these libraries. I have uploaded the GCM model data, and here you can see this one piece of code is used for the missing data handling, if any. So if any missing value is there, it is replaced by its mean. Then the data is standardized, and then after standardization, principal component analysis is performed. So, and then Scree plot is plotted, which you can see at the end of the code, where variance is plotted against the principal components. And again we have, this is the bubble chart which is used for the principal component loading. It will highlight the most influential GCM models which will be used later for the multi-model ensemble. So usually we select top three models from this analysis based on the principal component loading. So here you can see this is a Scree plot. These are different principal components, and here you can see this principal component 1 explain 38% of variance, and then followed by the other principal components. So in this study we will select the first principal components because it explained a higher portion of variance. So, and this one you can see this dotted lines basically shows the cumulative variance, just like this one. This is 38%, and then add this principal component 2 variance and this one 38, you will get this one, and again add the principal component 3 variance in this one and you will get this, and so on, and up to this one, you 100%. Now as I have already mentioned, we will consider the first principal component, which is this one. This one is the first principal component. We will consider this one. So this is the loading of the principal components. These are the GCM loading. So basically these three have the higher loading. So these models, this one, and this one, this will be selected for the multi-model ensemble computation, and the rest will be discarded.